Okay, ladies and gents, for our final video in topic 4.2, we're going to talk about how to write a net ionic equation, including the complete ionic as well as the molecular equation. Right? Net ionic equations show us specifically what types of solids will form. So for instance, some reactions with ions will produce a solid, and then what we will need to do is we will need to take that solid product and write its own equation for it, its own balanced equation. We call that equation the net ionic equation. There's a series of steps that we need to do in order to get there. And that also includes reviewing a new reference sheet that I gave you called the solubility chart. Alright, so let's start with this equation right here. 2 moles of potassium hydroxide react with 1 mole of zinc 2 fluoride to form zinc 2 hydroxide and 2 moles of potassium chloride. You'll notice that we have states of matter for these two reactants right here. They're both in the aqueous phase. However, we do not know just yet what the states of matter of these products are. And in order to figure that out, we're going to need to use our solubility chart. Solubility chart tells us what types of molecules, or what types of ionic compounds are soluble in water and which ones are not. So if we open up the solubility chart, which is found on Google Classroom, we can now take a look and see which, excuse me, which of these products right here, zinc 2 hydroxide or potassium fluoride, will be soluble or insoluble in water. Okay, so let's start with zinc chloride. Let's start with zinc 2 hydroxide. We're going to come up here and you'll see that the positive ions are along the top portion of the solubility chart. Okay. Looking for zinc 2, it's right here, Zn2+, and we are going to go down this chart until it lines up with the hydroxide ion over here on the left-hand side. And if we crisscross it correctly, we will see that zinc 2 hydroxide is insoluble in water. Insoluble means that it will not dissolve in water. So if you put solid zinc hydroxide in water, it will stay in the solid phase. Okay, so this right here is a solid. Alright, next what we'll do is we'll use our solubility chart to take a look at potassium fluoride. Okay, potassium fluoride. A good thing to know about potassium salts, as soon as you see potassium in it, it's almost always going to be soluble in water, meaning if I put anything that has potassium in it into water, it's going to dissolve. Okay, and when things dissolve, they become aqueous. But just to make sure, here's the potassium ion right here, here's the fluoride ion there, and when they crisscross on the table, come out to be soluble. Now, anything that is soluble in water will be considered aqueous. Okay. All right. Now that we know what our solid product is, we are going to need to now break down this whole chemical equation so that we can only keep the parts that we need that show up and make this zinc 2 hydroxide here. Okay. First things first. Any place where you see an aqueous, that means it's going to break up into its separate ions. We've gone over that before. Remember, aqueous things are dissolved in water, and the ions break apart, and they're surrounded by those water molecules. So our next step is to do the complete ionic equation. And we'll start with potassium hydroxide here. Let's not worry about the excuse me, the coefficients in front of them just yet. We'll worry about that later. Okay, potassium hydroxide is aqueous, so when it breaks up, it'll break up into K+, which is aqueous, and OH-. Okay, you should know by now how to break up ions in there, or how to break up ionic compounds into the separate ions. Okay, For zinc 2 fluoride, again, this is all on the product side still, we know that fluorine has a -1 charge, and there are 2 of them there, which means zinc must have a +2 charge in order to balance that out. So this is going to be Zn plus 2 aqueous plus F minus aqueous. And that takes care of everything on the products or the reactant side. For the product side, you see this solid ZnOH-, we cannot break that up because it is solid, so we are going to leave it as a solid. But we can break up the Kf because it is aqueous, and potassium will produce a K+ aqueous ion and an F- aqueous ion. That, ladies and gents, is the complete ionic equation. And technically what you need to do now is you need to go through and balance it out. There you go, that's balanced. Alright, now to get the net ionic equation, we are only concerned about the ions that are involved with making the solid. Remember, the net ionic equation takes that solid and only focuses on the ions that make it. So, going back, we're going to go through and we're going to cancel out things on both sides of this equation that are the same. So for instance, I have a 2K+ here and a 2K+ here. Cancel those out. I have a 2OH- here, but there's not a 2OH- over here, so that needs to stay. It also needs to stay because it's a part of the formula where the solid is. I have a zinc 2+ right here, but I do not have a zinc 2+ anywhere over here, so that needs to stay. It also needs to stay because it's a part of the formula where there's the solid. I forgot to put a 2 right here. And then I have a 2F-, cancels out with that 2F- here. So now I am left with only the things that are involved with forming the solid. So this is now our net ionic equation, in which I will take the 2OH-, which is aqueous, add that to the Zn2+, which is aqueous, to form the solid ZnOH2 solid. And that, ladies and gents, is the net ionic equation. Okay? Let's do another example. We'll kind of rush through this one because we've only got about 6 minutes left. Okay? Alright, so we have our balanced molecular equation right here. That's great. We now need to figure out whether or not these are solids or aqueous. Okay, and we need our solubility chart. Let's start with the sodium chloride, the NaCl. Okay. Good thing to know about sodium salts: if there is sodium anywhere, they are almost always soluble. So if you look at this whole column right here for sodium, everything is soluble, including sodium chloride, which is salt. So we're going to go ahead and remember, if it's soluble, it is aqueous because it will dissolve in water. Alright, now let's look at lead-2 sulfate. So here's Pb2, and let's look for sulfate, SO42-, crisscrosses right here as insoluble. So that means this is solid. Now let's go through and break up all of our aqueous ions and leave together our solid ions to make the complete ionic equation. Alright, lead 2 chloride is aqueous. Chlorine has a 1- charge usually, but there's 2 of them there, so that's a -2 charge total, which means this one lead needs a +2 charge. Again, you guys should already know how to figure out the charges on ions. Alright, sodium sulfate, okay? Sulfate has a 2- charge if you check your polyatomic ion chart for that, and you already should know by now that sodium has a 1+ charge. That's why there's 2 of them there to balance out that -2. So we have a positive charge on the sodium, which is going to be aqueous, and then a -2 charge on the sulfate, which is also aqueous. Reacts to form NaCl is aqueous, so that's going to form Na plus aqueous plus Cl minus aqueous, and then the lead sulfate remains solid. Now we got to go through and balance this. There was a 2 there, 2 here, 2 here, 2 here. Now we go through and cancel everything that's the same on both sides, okay? And remember to leave anything or any ion that is involved with making the solid, the PbSO4, okay? So that Pb2+, we need to leave it because it's a part of PbSO4. The Cl- is not a part of the PbSO4, and then the same on both sides, so those can go away. Same with the sodiums. And we need to keep that SO4 2- because SO4 is in the formula for the solid. And now we are ready to do our net ionic equation. Alright, we have Pb2+ aqueous plus SO4 minus 2 aqueous reacts to form the PbSO4 solid, and that is the complete and balanced net ionic equation. The net ionic equations, ladies and gents, show us what solids are forming when we're dealing with ionic compounds reacting with each other. Okay, I'm going to give you a couple of more examples in the Nearpod lesson. Go ahead and work through those, and we'll see you back for 4.3.